Bismillahirrahmanirrahim. Assalamu alaikum, my dear students. Uh, the topic which we were doing in the physical classes was Pythagoras theorem, and in the online classes again we are going to take start with the Pythagoras theorem. The topic has been mentioned interestingly in a short video. Please watch the video and then we'll start the questions.
Another one. MC Ireland.
I love geometry. Square the leg A and then square the B. Add these squares up equal to square C. Pythagorean theorem like a mathlete. Hypotenuse, what you call it? Long side legs drawn. To get a fill you can't afford it. Pythagorean theorem is important. Give me the A and B so I can find C. Check out the right triangle with the 4, 3. Square these numbers up like a mathlete. Add them up, slow down, it's not a track. Square root each side, don't be mad at me. Triple 3, 4, 5, that's Pythagorean. 6, 8, 10 like a triple team. Forget about the 5, 12, 13. Three triples, you can fill up the whole screen. Let me show you another problem that you've never seen. Follow all the steps, please don't try to daydream. We got a triple going round it if it isn't clean. I love geometry. Square the leg A and then square the B. Add these squares up equal to square C. Pythagorean theorem like a mathlete. Hypotenuse, what you call it? Long side legs drawn. To get a fill you can't afford it. Pythagorean theorem is important. Now let's analyze a problem where you're given C. And the mission is for you to find the A or B. You already know the steps, it's not a mystery. The only difference is in the subtraction property. Square root each side, this is trickery. 6.7, that's what it's supposed to be. Every single day we see making that history. Let's finish up with the converse and inequalities. You'll be given 3 numbers to substitute these. If the C squared is greater, then a 2 such a figure. If the C squared is less, then a cube is the best. If the C squared is equal, then you know the rest. I love geometry. Square the leg A and then square the B. Add these squares up equal to square C. Pythagorean theorem like a mathlete. Hypotenuse, what you call it? Long side legs drawn. To get a fill you can't afford it. Pythagorean theorem is important.
Okay, the first question, dear students, I hope that I hope that you have enjoyed the video. So let's take start from the questions. So the first question, which is displaying in front of you, that is about the word problem. I have drawn a picture in front of you that this is the ladder. This has a length of 6 meters and it is reaching up a wall, a vertical wall, right? And the distance between the foot of the wall and the foot of the building is 1 meters, right? So these 3 things are making a right angle triangle. So the Pythagoras theorem, we know that apply on a right angle triangle always. So and this theorem, why we apply this theorem on a right angle triangle? The purpose of this theorem is used to find out any missing side of a right angle triangle. So in this picture, in this practical based questions, we have 2 sides given. 1 meters is the base, 6 meters is the hypotenuse, because it is here we have a 90-degree angle on the vertical wall, and in front of this we have 6 meters, which is the hypotenuse, right? So if we solve this question, Pythagoras theorem says that hypotenuse square is equal to base square plus perpendicular square. This is the theorem, this is the equation, right? So 6 meters is the hypotenuse, base is 1 meters, and perpendicular we have to find out. This is the height of the wall. Actually, this is we have to find out, right? So the square of 6 is 36. The square of 1 is 1, like this. We move this 1 to the left side. 36 minus 1, that is 35. And in the last step of every question, we know that we take square root because we have to remove this square. So when we take square root on both sides, we get 5.9. So 5.9 meters is the height of the wall, right? We have found out this height of the wall, which is the perpendicular actually in the right angle triangle with the help of Pythagoras theorem. So in the next question, this question is from exercise 10B, question number 6, right? I have solved the question for you. Just I am going to explain the question. In this question, you can see that this is the question actually, right? In this question, what is the question actually? If you read this question from the book, that we have two vertical buildings. First is 37-meter high, and the second building is of 30-meter high. One building is taller, and the second building is shorter, right? These buildings are attached with the help of cable, and this cable is attached to the tops of the two buildings. So this is the cable actually. This is the cable actually, right? What is the requirement from in the question? We have to find out this length of the cable. We have to find out the length of this cable. And the distance between that two buildings is 16 meters. Okay. So ultimately, in this question, we have to draw a right angle triangle. So we have to see where should be the right angle triangle, from where we can find out our requirement. So if I draw an imaginary line here, like this, okay. This imaginary line, now after drawing this line, this is the rectangle, this one, right? And in the rectangle, the opposite sides are same, you know that. So if this is 16 meters, this should also be 16 meters. If this is 30 meters, this should also be 30 meters, right? So this is 30 meters, this one. If we subtract 37 meters, if we subtract this 30 meters from 37 meters, we will get this portion, which is the actual height of the triangle, of the right angle triangle. This is the thing, right? This is 7 meters. 37 minus 30 is equal to 7 meters. This is 7. So now we have two values given in a right angle triangle. 16 meters is the base, 7 meters is the height. Now we have to find out this length of the cable, which is the hypotenuse in the right angle triangle. So now you can see that this is the solution theorem. I have written the theorem. Then base is 16, perpendicular is 7. I have opened the squares. The square of 16 is 256. The square of 7 is 49. When you add these two values, you will get 305. And in the end, you have to take square root. And when you take square root, the answer will be 17.5. So the length of the cable is 17.5 meters. Okay. So a very interesting question, a very practical based question. From this question, we have found out the cable of length. So next, now move towards the question number 9, which is again from exercise 10B. Last question in today's lecture. In this question, I have drawn the diagram in front of you, and again I am going to read the question before you. Two spotlights P and Q are mounted on a vertical pole AB. Light beams from P and Q shine to 2 points on the ground, H and K respectively. Given that PQ is 12.7 meters, KB is 7.2 meters, PH is 39 meters, and QP is 21 meters. Find BQ, the height above the ground at which the spotlight Q is mounted. So this is the diagram actually, which I have read from the book, the question. This is the diagram actually, and in this diagram, these 2 points P and Q. On point P, this is AB, a pole, a vertical pole AB. It could be any pole. On point P, we have a spotlight which has a light beam on H point on the level ground. This is spotlight Q, which is falling a light beam on K point on the ground, right? So, this is in this diagram we have two right angle triangles. One is QBK and second is PBH. And in this composite diagram, we have one common side which is PB. Perpendicular is common, right? So what we have to find out actually, we have to find out BQ in first requirement. And what is BQ? BQ is the height at which BQ is the height at which the point spotlight Q is mounted, right? So I have solved the solution before you. You can see the solution. This I have taken this triangle out from the main diagram. This is the smaller triangle. You can see in this triangle 17.2 is the base, 21 is the hypotenuse. We have to find out BQ, the height at which the spotlight Q is mounted above the ground, right? So apply the theorem on this shorter triangle. Hypotenuse 21, base is 17.2, and perpendicular we have to find out. Open the squares with the help of calculators. 21, the square of 21 is 441. The square of 17.2 is 295.8. I have told you the method to find out the square root from the calculator in the class, in the physical passage, so you can find out, right? So because we have to find out P, we have to subtract the values. So move to 95.8 to the left side. It will be subtracted from 441. The answer will be 145.2. And when you take square root of this value from the calculator, you will get 12.05. So 12.05 is the actual height at which the spotlight Q is mounted above the ground. This is the height. Okay. Now move towards this is the second question. Do not see this question now. This is the main requirement and the first requirement. Now move towards this requirement, HK. What is HK actually? HK is the actual distance between the two light projections. Meaning on H, a light beam is falling from P point. On K, the light beam is falling from Q spotlight. We have to find out the distance between these two light projections. So now for finding HK, we have to take a bigger triangle. Okay. In the bigger triangle, again I have taken the bigger triangle out for you. This is the bigger triangle. Okay, I have missed this smaller because we have found out this thing. So now I just the bigger triangle I have taken. In this triangle, 39 is the hypotenuse. Okay, and what is the perpendicular? PB is the perpendicular. Okay, 12.7 is given in the question. PQ is given in the question. BQ we have found out in part number 1.05. This is 12.05. BQ. So when you add this is BQ and this is 17 and this is PQ. When you add these two values, you will get a total perpendicular, and that is 24.8. Okay, so apply the theorem. Hypotenuse square as 39. 39 square is equal to HB. HB is the main base. For finding HK, we have to find out the main base, HB. So HB is the main base, 24.8 is perpendicular, right? This is open the squares. The square of 39 is 1521. The square of 24.8 is 615.04. Move this value to the left side, subtract these two values, you will get 905.96. And when you take square root of this value, you will get 30.1 meters is HB actually. So this is HB 30.1. Now we have to subtract 17.2 from 30.1. You will get HK, that is 12.9. Right? So I have solved 3 questions in today's lecture. I am going to attach a worksheet along this lecture. I do that worksheet must because it will create a better understanding of these questions of word problems. So today's lecture has ended now. See you in the next lecture. Till then, stay blessed, stay happy. Allah Hafiz.